Okay, ladies and gentlemen, let's talk about the area of regular polygons. So, for the area of regular polygons, obviously, in any polygon that's regular, it means all sides and all angles are the same length in spite of my awful picture. And the area for that is 1/2 AP, where A is the apothem, P is the perimeter. So, for example, if I have a hexagon, and that hexagon has a side of 5, but we know it's regular, that means all sides are going to be 5. Now, we also know that all the way around a figure is 360 degrees. And in a hexagon, it breaks into 6 different triangles. So each triangle has a 60-degree angle at the top. So divide by 360 divided by 6, 60 degrees. Now what's really nice about 60 degrees is if I drop an altitude, that 60 becomes 30 and 30, and then 60 over here and 60 over here. And so now what I really have are two 30, 60, 90 triangles. And instead of 5 all the way across the bottom, it's 2.5. So if the short side is 2.5, I can use special triangles, 1, root 3, 2, 30, 60, 90, and say, hey, 2.5 goes with 1 as thing I don't know, goes with 2. And cross multiply and find out, oh gosh, that looks like 5. And so then I want to find this side over here. I want to find y, or I want to find the altitude or the height. So I can say h goes with root 3 as 2.5 goes with 1. And so I have h equals 2.5 times root 3. Now it's strange to see a decimal and a root together, but it's still more accurate than rounding everything. So what I really end up having is a hexagon with an apothem of 2.5 root 3 and sides of 5. So the apothem equals 2.5 root 3. Perimeter would be 5, 5, 5, 5, 5, 5, 30. So the area equals 1/2 2.5 times root 3 times 30. Put it all together, and that's my area formula. So that is using area equals 1/2 AP. Little a is the apothem, P is the perimeter. In this case, I got a 60, so I can use special triangles. But I can't always use special triangles. What if I have a 5-sided figure? So I have a pentagon with side 6. And of course, this only works for regular. The problem is when I break this into triangles, I have 360 divided by 5. And if I have 360 divided by 5, that's not going to be one of my special triangles. 72 degrees. So 72, 72, 72. And if I cut it in half, that's 36 and 36. So now I have this triangle with 36 degrees with what was 6. So now I have 3 here, 3 here. And I still need to find this value right here. Well, if I have 36, I know the opposite is 3 and the adjacent is y. Opposite, adjacent, that's going to be tangent. So I can say tan of 36 degrees equals 3 over y. Now I can cross multiply. Y tan 36 equals 3. Divide both sides by tan 36. So I simply take 3 divided by tan 36, and that gives me 4.129. So y equals 4.129, 145, blah, 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 blah. So if I want the area equals 1/2 apothem, which is 4.1291, times perimeter, well, 6, and there's 5 sides, so that happens to be 30 again. I multiply by 30, divide by 2. Answer is area equals 61.937, da, 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 da. And I can round it to whatever it asks me to round it to. So that is area using apothem and perimeter and special triangles. It's also using trigonometry, but sometimes it's not that difficult. Sometimes they simply give us everything we need, and they say, oh, there's 6, and this is 4. So in this case, if I have 6 for an apothem, and I have a side of 4, that means my perimeter, 1, 2, 3, 4, 5, 6, 7, 8, is 32. So I simply say 1/2 of 6 times 32, and that's all I have to do to get the area. Likewise, let's say they give me the area, and they say, the area is 72, the side length is 4.5, find the apothem. Well, area equals 1/2 AP. I know that the area is 72. I don't know the apothem, but the perimeter will be 4.5 times 1, 2, 3, 4, 5. So 4.5 times 5. 4.5 times 5 is 22.5. And now the only thing I don't know is A, and I solve for A. So it's a fairly basic formula, but sometimes to find the apothem, you're going to have to use special triangles, or you're going to have to use trigonometry. So all that stuff that we've used comes right back into play.